Hi again, my dear AS students. I wish you did watch the first lesson on the first part of dynamics. We are in dynamics part 2. We are in dynamics. We finished part 1. We are in dynamics part 2. We are in the case now today. We are in the case. We finished case 1. That the particle moving on a smooth surface. To remind you quickly, what did we finish in the first part? I remind you quickly in fast diagram. This is, for example, a particle here. This is F3 Newton. This is force of F Newton. This is force of F2. And the particle moves in this direction, accelerates in this direction. So the equations of motion are two cases: in the direction of motion, or we say horizontally. The direction of motion is here, so this is the parallel, this is the force in the direction of motion and parallel to the direction of motion, which is F3. So F3 is the main force. It's very important to understand always in mechanics. We have two forces opposing it, so we add them. F3, F1 and F2 oppose F3, so we add them. Why we subtract? Because F1 and F2, they oppose the main force, is equal to MA vertically or perpendicular to the plane. R is equal to the weight. This that we finished in the first case. I wish that we follow the videos lesson by lesson, day by day, to be able to understand this in easy and simple way. Case 2 now. This was case 1, the first case. And remember, this surface is smooth surface, smooth surface. Today we'll be dealing with rough surface, the friction force. After a few minutes, you will distinguish and recognize why we're saying smooth and what's the difference between them. Our case today is if a force resolving forces, or a force that is applied or acted at an angle, my dear students, at an angle to the direction of motion. To the direction of motion. I will sketch you before we start in details. And what do you mean? This is that we are talking about. This is a particle of m kilograms, and the force, for example, this is force P newtons, acts or applies at an angle, at the angle alpha to the particle m. What happens here? Let's see what will happen in this case. How do you resolve this force, or such a force that makes an angle to the horizontal? Since again, I will draw it here a little bit in a larger way. This is the particle m, and this is the force P newtons, acts the particle at the angle alpha, my dear students. We have to understand first that this force now does not affect the motion. Does not affect the motion. What do you mean by this? This is the force, since the force is not in this direction or in this direction, my dear students. So this force is just for direction, for showing the angle. These parts of the force, that they are called components. So I will write, what did I say now? Since P Newton, since the force P newtons is not horizontal or vertical, so it must be resolved into two components called components. Two components. One, it is adjacent, and one is opposite. And we use this language from trigonometry, you understand now. What do you mean by this? Let me explain this quickly. This is P here, then I will draw them on the diagram here, resolve forces on the same diagram. Alright? Assume that P newtons is the hypotenuse of a triangle. This is P. And this is a right angle triangle. And this is alpha. We know from basics of trigonometry, this is the adjacent, this is the opposite to the angle. This is the opposite. And this is the adjacent. So if you'll be writing this side, yes, what we'll be doing? Cosine alpha is equal to the adjacent over P. Adjacent over hypotenuse. Yes? K, you remember SOHCAHTOA? All of us, we remember SOHCAHTOA. Yeah? S, K for cosine, adjacent. So this will give, what it will give? The adjacent component, it will be P cosine alpha. P cosine alpha. So in this case, relate to what I'm doing here. This is the adjacent component. So the force P, this direction is the adjacent component, which is P cosine alpha. At the same time, the same thing, this opposite, how can I write it in terms of P? Since sine alpha equals opposite over the hypotenuse, which is P, this implies that the opposite component is equal to P sine alpha. Back to the diagram. So this component is that J. Look well here. So this is the side. True, this is the opposite. This is parallel of it. So if this is opposite to the angle, so this is opposite to the angle. So this is P sine alpha. P sine alpha. Explaining more, my dear students. Example 2. This is particle of m kilograms, and look at the force. The force acts like this, and this is the angle theta, let's say, and this is P newtons. When we are given the force like this, advised to see it well, extend it like this. Extend the force. So this is the force acting. So if this is alpha or theta, so by vertical opposite, this is theta as well. If you don't see it well, because of this shape, let me show it as a point. What do I mean? To make it easier to you. This is, I'll make it small just to show you simpler how to do this. This is the particle, point or particle. This is the force in this diagram. And this is the angle theta. So the force acting in this way on this particle. I draw it small for a purpose to show you easier, to see it easier, simpler to you to understand. So this is the P, Newton's force, and this is theta. What will happen here? So it will be challenging to see it like this. So when you are given questions like this or the sketches like this, extend the force like this. You'll see it more. You'll understand faster and easier. So this is the P, extend it. By basics of geometry, if this theta, so this is theta by vertically opposite. So look, this is the adjacent component and this one is the opposite component. Near to the angle, look, near to the angle. So this is P cosine theta and this is P sine theta. According to the position of the angle or how the force acts on the particle, we resolve the force. Don't forget this fact. This is the key statement we said before and I will say it again and again many times. What will change here, my dear students? So it will be more clear in example 3. Compare now, it's the first important example, how it will affect, what's the difference between these questions and the questions that we did in part 1 or in case 1, in dynamics 1 in the chapter. For example, this is a particle of 4 kilograms and the force 20 newtons, look, force 20 newtons, act at this force at the angle 30 degrees. Again, this is the force 20 newtons, acts on a particle with 30 degrees. Very simple question, find A. The question wants, find the acceleration of the particle. Find, I'll write it in words to consider the students, they are not like, they don't have background, strong background in mechanics or physics in O level. Find the acceleration of the particle. Okay? What's the difference here? Focus again, I will say it. This, the force does not, Newton 20, this, as it is, it doesn't affect the motion. These two components, they affect the motion. These two. So this 30, this is the adjacent, the near one. So this is 20 cosine 30. This is 20 sine 30. And remember, this is smooth surface. No other forces acting. And we remember from before, we have reaction force. Don't forget these two natural forces and the weight. So when you do this, what will happen? Look what will change. In part A, we want A, the acceleration of the particle. So part A, to find the acceleration, what do? We in the horizontal or adjacent component, the direction. We are in the horizontal, we can say here horizontal in this example. In this example, it will be inconvenient if you use horizontal and vertical for the whole examples or problems in mechanics. You'll understand later today what do I mean when we start inclined planes and other examples. So to find A, 20 cosine 30, it's the only force in the direction of motion because it's F cosine the angle. Look, 20 cosine, it's the only force in the direction of motion, this one, is equal to 4A MA. Then we calculate 20 cosine 30 So this will give a 20 cosine 30 divided by 4.3343 significant figures meter per second squared. Easy? Look how the equations of motion will change now from case 1. Part B, we want R, find R. Do you remember when the last note in the previous part that I said it's not always R equals mg. This is an evidence now. This is the first example. So write the vertical or perpendicular to the plane. What are the forces? It's R in this example plus 20 sine 30, my dear students, equals to 4 times A. And we found A from here. 4. This the students do. Look, I'm showing you now. Mistake in the exams. We are replacing A here. Remember, R is equal to 4G. So directly 4 times 8. 9.8. In the previous, because I maybe said it fast last seconds, in the first case, R was only equal to 4G. In this case, no, we have a new force, my dear students. So we have a new component appears. So R and this force in the same direction. R and this force in the same direction. Because of that, we add them. Yes? Is equal to the weight of the particle, which is in opposite direction. So R is equal to, in this example, by calculator, 4 times 9.8 multiply, you will get 39.2 minus 20 sine 30, it's 10 when you calculate it. It's 10. Use the calculator for this, is 10. Sine 30 is half times 10, 20 is 10. So it is 29.2 newtons. Look at the difference, how the equations of motion change when we have forces. A new force acts or applies at an angle to the particle in the direction of motion. Let's do another example. Example 3, to understand more. Practicing is very important in mechanics, more than important than solving past papers or problems without understanding. My dear learners, especially that the majority of the students, they get A to A star in O levels, and they do unfortunately bad, like E to D in M1, like across the board, because we solve the problems, use the calculator without understanding the case. So you have to understand the case, my dear students. All right, example 3. The particle is 5 kilograms, and we have force like this with P newtons, and you are given the angle 36.9 degrees, and you are given in the question A is equal to 8 meters per second squared. Part A, find P. Part B, find R. This is a question like it's one of the common questions in M1, but this is easy, of course. We're still in the easy problems. But I have to write the information sufficiently in the basic questions to be able to write them correctly and accurately in the harder ones. Basics are important. Okay, since the angle is here, so this is the adjacent one, this is the opposite one. So this is P cosine 36.9, this is P sine 36.9, and we have R, and we have 5g, the way to the gravity. Part A, to find P, my dear students. We are where? Of course, if someone wondering on why we didn't show, it's clear that the particle moves in this direction. Because it's the only force, look at it. So the force in the direction of motion is this, in such problems. So here is horizontally, or in the direction of motion, P cosine 36.9 is equal to MA, 5A. 5A. We are given A is 8, so this implies that P cosine 36.9 is 0.8 in the calculator. Calculate with me if you have calculators, or when you watch, don't just mentally, make sure that you are finding that these answers. Calculate them. Is equal to 40, 5 times 8, which is 40. So P is equal to 40 dividing by 0.8 gives you 50 newtons. 50 newtons. All right. To find R in the perpendicular to the plane. We are in vertical motion, direction, perpendicular direction to the plane, or the surface of motion, or the direction of motion. Here again we have a new component. So R plus P sine 36.9 is equal to 5g. R that he wants, P is 50, now we know it. Sine by the calculator is 0.6 is equal to 5 times 9.8. So this is 49 newtons. So R plus this times this is 30. So R is equal to 49 minus 30 gives us 19 newtons. The reaction force is 19 newtons. Do you see how now we resolve the forces acting at an angle to the horizontal? It's very important. The language, the notation is very important in mechanics and or physics in general. Now the next will be defining the next part's friction force, how the friction will be affecting the equations of motion, and what does friction mean. Then we'll move to the inclined plane problems. Then we'll move to the next part, to the inclined plane problems. For this lesson, to not make it long, make sure you understand this to move to the next part. I wish you understanding and enjoying the lessons in M1 so far, and thank you so much.